All right, so today's topic is slightly interesting, and before we dig into what is interpretation in general, how many of us here kind of build models on a daily basis, or have an understanding of what interpretation means? Can you see some show of hands? Cool, awesome. Yeah, just asking to me to show that we don't pass the mic to you so that you guys don't ask difficult questions to me. That's the only reason. All right. So before we get started, since it's a hands-on session, without wasting any time, let's get our environment set up. So if we can all go to the URL, aquarium.h2o.ai, and I'll work with you guys as well. So it's the same environment that I'm using. Okay. So once we are there on the Aquarium screen, the first thing that we're going to do is create an account on our lab environment. So how are we going to do that? So we're going to click Create New Account and then enter our basic information. Put this a little back. All right. Cool. And then we'll ask to generate a password. So if you do that, you should, if it's successful, all you guys should receive an email with a temporary password. If you were able to launch the instance, on the bottom right, you would see this URL. And with that, we should be able to launch a driverless AI instance. So right now what we're looking at is an empty environment. I don't have any data sets, any experiments, anything, as any of you guys. So we are all on the same page. So as we're doing that, let's keep the screen there for a bit and go back to the slides. Cool. So with that, just a little bit more information about myself. So for those of you who didn't get to know who I am, so my name is Pramit Chaudhary. I've recently joined the creative and talented H2O team as a lead scientist here. Before that, I used to be a scientist at this company called datascience.com. It got recently acquired. So by hobby, I'm an applied research scientist. I work on different aspects of ML, and recently I've been exploring different ways of evaluating and extracting information out of a machine learning algorithms. And we'll touch base and we'll dig deeper into that as to what does that mean. But before that, sometime in my past, I also used to build models for doing matchmaking. So I have a little bit idea about that domain, what those algorithms do. So if you guys have any questions, I'll be more than happy to take it. All right. So in order to make sure that we all are on the same page and we are on this journey together, let's just quickly recap what do we mean by the ML workflow? What are the components that make an ML workflow? So typically when we get any data set, the first thing that we don't know is that, okay, there's a target function, we don't have any idea what that is, and we are trying to identify that so that maybe if we can train an example and apply an algorithm to it based on some hypothesis that we have thought. So for example, if it's a credit fraud that we are trying to detect, we get some data set, we create a training and test split on that data set, we have defined a hypothesis. Okay, we are trying to identify a credit fraud. And we have some assumptions that based on the data that we have, certain attributes are going to contribute to it. So with that assumption, we go ahead and we build a model. And then we try to validate that final hypothesis. When that happens, we are constantly trying to evaluate a model. So like terms like accuracy, AUC, precision recall, R-square metrics, does any of these words make any sense? We are familiar with it. For the others, it's some metric or scalar metric that one could think of. It could be as simple as y is equal to ax or something. And we are trying to observe that if we are trying to optimize a model, can we reduce or increase that particular metric in order to validate our hypothesis? But what we are doing is that we started with an assumption. We got some data, we started with the assumption, we want to build a model, and then we want to understand it. We want to evaluate it. In that notion, today we're going to talk about the idea of interpretation, which is a deeper understanding of the model. And we're going to define together what does that mean. But the objective there is that once we do that, once as we are evaluating it, how can we bring in human in the loop to get those inputs and feed it back into the data that we had started with so that we could improve a model? Because at the end of the day, we are all striving to improve a model so that we could perform the best way possible. So adding more picture to what the previous slide that we just showed, we capture in the driverless AI those components pretty close, right? So as you can see in this page, we have various components. We have an aspect of project management that we're not going to touch today. But once we get the data, first we want to visualize it. So we have a component for auto visualization. We want to do feature engineering because once we have a data, we have to extract features out of that so that we could do some modeling on it, right? Once we do that, what we are trying to do is it's a constant phase of experimentation. And we will quickly understand what do we exactly mean by experimentation as we go back to our demo environment. But as we are constantly doing this experimentation, what are we trying to do? As we are talking about, we are trying to evaluate, interpret, extract information out of the model that could help us improve it. That's the core objective. So that's the environment. It's an interactive playground that we have where user can come in and do experiments as desired. The auto ML component of that aspect is that can we automate the feature engineering aspect so that one doesn't have to worry, so that each one of us in this room can build a model. And the interpretability aspect of it, as I was mentioning, is to how can we bring in human in the loop? Because some of it over time may become expert of a particular domain, and we may have intuitions that we may want to capture in a certain way. So the problem with machine learning in general is that it's a very domain-specific application. So part of our effort is that how can we automate the generic part of it so that if solving of a problem is 100%, we can at least make you reach 80%, and with interpretation, the last 20% is enabled. So a quick recap or summarization of the problems that driverless AI covers.
You said the last 20% is a...
Sorry, so what I mean is that
I just didn't hear the word. What was the word?
So what I'm saying is that if you think in terms of percentage and you define a problem by, say, you have a problem which is of 100%, define a percentage. With the auto ML ability, we're trying to solve the 80% of the problem. And when we're trying to bring in interpretation to it, we are enabling how a domain expert could step in and improve that model. Because the idea is that ML, like I was saying, that it's a very domain specific. As we can see on the screen, it could range from text to image to unstructured data to tabular data. It could be numeric. It could be, so for example, it could be in the domain of finance. It could be in the domain of matchmaking. And even the same model that works or the same use case of fraud, which is in finance, may not apply in case of matchmaking. Well, because the criteria are different, which means that the signals which will be actually contributing to the success or failure of the model would be very different as to what it will be in a finance industry as to what it will be in a matchmaking industry. Does that help?
I just want to know the word.
Oh, okay, sorry. No worries. My apologies. So the focus of this aspect is that what we're trying to solve here is supervised learning problems. So do we have an understanding that most of the ML problems could be divided as supervised and unsupervised problems? Yeah?
What do you call time series then?
It depends on what we're trying to do, but in this case, it's a supervised learning problem. So for example, if you're trying to predict weekly sales based on some historic data that you've seen in the past, we capture it as a time series experiment, and using that, we solve it as a regression problem.
Oh, regression.
Yes.
Anyway, so that's a regression.
Yes.
It's not a time series. Anyway.
I mean, it's still a time series problem because one problem with the time series data is that the data are sequentially dependent. And for most of the ML problems, we want to solve it as an IID where all the data points are independently dependent, right? Cool. All right, so now let's together define what do we mean by interpretation quickly. So the idea with interpretation is that how can we explain and present a model in a most human understandable way? We enable us to query the model as to why did you get to a certain conclusion, what did you consider as the strongest signal, and why did you consider the strongest signal. So what we are trying to enable is what, why, and how. The core objective is that, as I was mentioning and talking earlier, that when we want to evaluate models, I use terms like R square, AUC, and some other model metric. For some of us, it makes sense. For some of us, don't. But all of us together in this room, we can always relate to what is the input, what is the output, and if we can summarize the output based on the input that we see, then we all together as an audience can say, oh yeah, this model is doing as we expect it to do. So that is one definition of model interpretation. So we went ahead and we also asked one of the experts in this field of machine learning as to how does he define interpretation. So interpretation, as according to the expert, Professor Samir Singh from UCI, is a collection of visual artifacts. Anything that could help in describing in depth their description of the model behavior, so which could enable ideas as to how it is performing the task, and in a way, can it enable to trust the model that got built? Can we trust the prediction that is coming out of it? And in that way, as we bring in human in the loop or the domain expert, can we, using that insights, can we improve the model? Does any of those words make sense? Are we on the same page? Some ideas? Yeah? Some of my colleagues have written an awesome book on this topic. And it should be available online to download as well. But if not, I'm sure we can find some copies as well for you guys for more in-depth understanding. Cool. All right. So I use some terms around model interpretation and what it is. So now let's take a step back and understand this ideology. We together in a group this evening are going to build some model. What are we? Model makers. We're going to use that model, maybe give it to an engineering team, maybe give it to our peers, maybe give it to our bosses. And they're going to be asking us question, how do you know this model is good? Am I confident that this model is going to predict as good as what we already have? So maybe we can call this person as model breakers, because they are the people who are asking us questions. So if in a software paradigm, we have engineers and software developers and QA developers or engineers. And what are they trying to fight against, or what are they trying to achieve? Someone is developing the code, and the other one is trying to identify, did we cover the corner cases? So it's a very similar ideology. But what are we trying to do in doing so? When we are doing or making a model, the core objective is, how can we debug the model that we build? Can we explore and identify some of those features and interactions which are hidden, which we have failed to capture as domain experts? So we know that this model is built on a defined data set. And if the data set slightly changes, there will be a lot of variability. How can we control that? Can we do model comparisons? So can we compare apples to apples? Can we compare apples to oranges in some defined way, common understanding? For a model breaker's perspective, it's like, can you enable transparency? Because I have to share the results with a lot of my people. And not everybody is that mathematically sound or has that background. But we all, as an audience or as a participant in this experiment, want to understand the result together. So that's why the stress on the objective of, can we enable the explanations as humanly understandable based on input and output? So if we start with, if we have a data frame which is 10 rows, 4 features, we want to understand it based on the 4 features that got in. So can we enable that? And why does it become important is that, as we will see, we want to automate the process of model building. right? There are a lot of generic aspects like feature engineering, like building a model, selecting which group of models to build, depending on an experiment. Like you were asking about time series, it could be about NLP. It's an experiment. It's an experimental environment, right? And we don't know which model is going to give the best result. Can we automate that process? So if you're automating that process, then some people may come back and say, hey, you're giving me a black box, and I don't know what's going on. What are you hiding? Right? The other problem is there that we typically face in our industry is that shortage of talent, maybe. Right? So we get the data, and then maybe some of us are not that, are still like, getting our feet wet in the domain of machine learning. So we don't have this data scientist expertise, and so we're like, oh, we have to go out and get more talent. But maybe can we reduce that thing? Can we reduce the cost? Maybe we automate that process and give you a way, an interface through which you can explore what has gone into that black box model, and then evaluate for yourself without being an expert, is this model good or bad, right? So everybody on the same page? So we define model interpretation as a way to understand the model's predictions in the most humanly understandable way, based on input and output. Cool. Then quickly we're going to define what do we mean, like how do we cover this aspect of interpretation technically. So we'll define a scope, right? So what's the scope of interpretation? Whenever we get a data set, as you could see on the screen, we say, suppose you have 100 rows. One, you want to generate explanations which could cover those 100 rows. But we want to pay close attention to individual predictions as well. So for example, if you have 100 rows and I have an accuracy of 90%, which means 90% of the time I got 90 rows from the data set correct, 10 of them are wrong. How can I understand what's going on with 10? So now we want to define it as capturing it locally. Hence the scope that you will see on the screen defined as globally and locally. So what does globally mean? Being able to capture the conditional interaction between the features, which we can call it as the independent and dependent variable. As I was stressing earlier, that the focus right now is with respect to supervised learning problems, so we always have a target variable. It could be a classification use case, it could be a regression use case, right? But we always have a y. And we're trying to automate the process of function of x so that you don't have to worry, and enable an interface so that you could query that function of x. And we want to capture it globally, that is considering the whole data set, and with respect to individual points, that is locally. Are we good on the scope, right? Cool. So with that, let's start getting our hands dirty, okay? So we're gonna try, with the amount of time that we have, see if we can build two types of model. One would be a classification, which we're gonna be using the Titanic dataset. How many of you guys here are familiar with the Titanic dataset? Okay, we see some raise of hands. Okay, we're gonna capture what that is. And we're gonna also cover a regression use case where we're gonna predict sales. And Walmart dataset, using the Walmart dataset. How many of us are familiar with the Walmart dataset? Okay, cool, all right. So let's see what the data looks like quickly. Oh, actually, we'll do it in the experiment itself. All right, cool. So let's go back to our environment, the driverless AI environment that we have created, and we'll explore these two data sets together.
So do you want them to follow you, or are you going to show and then follow you?
They can. I think it would be great if we just follow together. So we'll keep it interactive, right?
So basically, at this point, now jump back to your computer, tab back over, make sure you're here, because now you're going to follow along, or else you fall behind.
Yes, absolutely. And we are not going to let that happen. And we're going to build two models together before the evening ends.
Could you show me the link for the license?
Sure, absolutely. Go back. Dive into H2O. Just waiting for a friend here. Oh, no need. No, yeah. The environment is all equipped with all the data sets. We are trying to make it as easy as possible for everyone in the room today. So like I was saying, the objective is that we get you guys some sort of a license so that tomorrow if you're going back to whichever company you're working for and somebody's building a model, build a model with driverless AI and maybe challenge the person or the data science expert there. Sure.
You talk about machine learning.
Right.
You've got hundreds and thousands of domains.
Right.
For every domain, you have to have some data.
That's true.
And then you have to teach that particular machine on that data and apply the human, to see and then iterate it till you come to the right answer.
Absolutely.
That's the problem.
Right.
So the machine learning, as they talk about, will the machine catch up with human beings?
Right.
At that rate, it will catch up in about 1 million years. Right?
Maybe in some aspect it has, right? So like for example, like I don't know if you know, like a lot of the Amazon warehouses are they have been automated with a lot of robots who actually try to manage the storehouse and stuff like that. A lot of inventory management systems are there. We automated like even simple use cases of fraud detections and stuff, right?
So you're saying the more the data on a particular domain we have,
Right.
the more learning we get, and then we try to teach it and iterate till it meets our expectations.
So that is true that nobody can beat the amount of data that one has. But at the same time, I would also say that there's a lot of research which is going on as to how we can reduce the dependence on the data. So like part of the thing is captured in our offering as well. That's like, how do we do the feature engineering aspect? Can we do feature engineering even with the less amount of data?
So there will be, every time we dive into a particular machine learning or a particular domain,
Right.
we will have to revert to that particular machine which has that domain knowledge. Right?
You mean in terms of the model or?
In terms of the model.
Yeah, so that's the objective is that how can we automate that process so that dependence on that domain reduces, an expert reduces, right? That's what we typically do even with software, right? We get a problem, we hammer on it quite some time till we figure out what is the generic pattern. When we identify those generic pattern, we automate it so that we don't have to do it manually.
So I don't want to digress.
Sure.
So you talk about, today one of the biggest challenges
Yes.
today is
Yes.
security.
Right.
And I have seen hundreds of security
Right.
companies. But the reality is the company that has access to the most amount of data, can come up with the best knowledge. Who are the bad guys? Who are the attackers? Who are the hackers?
Probably. So that's why we have a lot of vendors who sell data, including Facebook, right? So, cool. All right. So let's get started. All right. First, we're going to do is, so this is our environment, interactive environment page for driverless AI. As my friend here was saying, we need data. So let's add some data. First, we click on add button. So add data set. We'll click file system. Click on data. The first model we're going to try and build is with the Titanic data set. So we're going to click other data. Second. Just give me 1 second. Still waiting. Okay. All right. Let me just make sure. 1 second. Just give me 1 second. Okay, no, it's not the other data. We go to small. Okay, sorry, it's not the other data, it's the small data. We go into small data, then GBM test. There is a folder called GBM test. And then third last is the titanic.csv. It's approximately 100 KB file. Can we all see that? Yeah, small data, then GBM test. Sorry, so it's data, then small data, not other data.
Oh, small.
Yes. And then GBM test.
The import file?
Yes, and for those who are already there and selected the Titanic dataset, please go ahead and say import file. We'll give ourselves a quick 1 minute. Data, small data, GBM test, titanic.csv. You good? Cool, cool. All right, so first thing after we have done or loaded the data, we are in an interactive environment and we want to understand what is the data about. So, oops, not this, sorry. This would be the next step. We click on details. So as you will see on the screen, if everybody is successful, we'll get a small visualization, which is capturing the summary of what the data actually looks like. So we have some columns in this data set. I don't remember, it's around maybe 10 or 12. It's passenger class, survived, did the people survive or not? So if you remember Titanic dataset, for those of people who are not familiar with Titanic dataset, it's to predict, depending from a dataset, can you predict which kind of people has the probability of surviving the disaster? There was a raise of hand in the back. Yes, sir.
Go back a step and
I certainly can. You're there on the page? Okay, so then you click on it and you should see a drop down. So after that I said details. Cool, cool. So what we're seeing here is a quick summarization of what the data would look like. So since we are also constrained on time, and remember core objective is all of us are going to build 2 models, right? So it may not be the best, but at least we'll build 2 models together. So quickly here, what we want to achieve with this data set is that we want to predict what's the probability of survival depending on certain set of parameters. And we're going to make use of our driverless AI offering to automate the whole process of, like friend was mentioning about what do we do? Well, we have the data, how do we do feature engineering, that aspect. So first thing we're going to do, as you saw, we saw the details, we're going to split it. So we're going to split between train and test. So we see the input screen in front of you guys. So if you guys can type with me, Titanic.
How did you get to this?
Oh, go back. We click here, say there's an option called split. Split, yeah. And then we get an interactive screen. Okay, so first in the output name, we're going to say Titanic underscore training, howsoever, Titanic underscore train underscore lab. In the output name too, we're going to say Titanic underscore test lab. And then we have this, you see this cool visualization at the bottom. That will help us select a ratio. So it's an interactive environment, so we can drag it. We can also click in the input tab there, and we can specify the percentage as well. 0.7. Okay. What's that again? For convenience, we can just use the slider.
There's a question explaining what the split ratio is.
Oh, what's the split ratio is? So once we, sure. So once we get the data, the first thing that we want to do is we want to split it between train and test. There are other things going on, but let's assume that we want to separate it into 2 buckets. Question is why? On one bucket, that is bucket 1, which you saw as output name underscore 1, we're going to build a model, right? But we don't want to evaluate the performance on the model that we based on the data that we used from bucket 1. We're going to use the bucket 2 data to see how good or bad my model is doing. So question would be why? Because when we are trying to automate the process of pattern recognition. So machine learning most of the time is just about identifying patterns, right? And patterns could be sequential, it could be random. So if we figure out a way to randomly split the data and make no assumption, we are asking or forcing an algorithm to identify what are the generic patterns that could help me predict or classify, or if it's a regression problem, give some value based on what it has seen. We'll hide some amount of data so that when we expose this model that we have learned to a data that it has not seen, then it's the true nature of it to understand how good or bad it is. Does that make sense to everyone? Cool. So that's why we want to split it. Cool. So let's do that. And let's say save. So if we are all successful, we should see on the screen Titanic test underscore lab, Titanic underscore train underscore lab. And since we had done a 70-30 split, that's why you'll see the number of rows for the train is 916. For test is 393. And we have 14 columns in this data set. One will be, we're going to define a y as a target variable. And the other 13, we're going to use it to make that prediction. And we see if we can do a good job based on, we'll train a model on bucket 1 and test it on bucket 2. Cool? Everybody's with me? Okay. So typically we want to keep, so if you say yes and no, I would say as well. So typically people do 70-30s because they want to keep as much data as they can for training. But the other question that may come up, what if I'm short on data? What am I going to do then? The other question that may come up is what, I have terabytes of data. So maybe I can do a 50-50 split as well, right? And if you're able to achieve awesome performance with that, I think that model is going to do extremely well no matter what.
But how did you come up? You may need 10 terabytes of data. Why 1 terabyte?
So that's why I say that's an experimental nature, right? So say somebody wants to, like maybe I have an idea because I've built this model so many times, I might know that if I do 70-30 split, I'll get 99% performance. But if somebody else is there, maybe he has another intuition and he says that I can get the same one with 60-40 split. So from an evaluation perspective, his model might be better than mine because I consumed more data. Right? Cool. All right. So, sure.
The test on the train doesn't add up to the size, doesn't add up. What is that? Like 49 plus 105, 106?
So the size could be an attribute of many different factors. If you want to compare the rows, then the best would be 393 plus 916.
So does it drop any rows like outliers, or it doesn't drop?
It will do when we get into the modeling aspect. That's the automation part. That's completely automated. It figures out what the outliers are. Based on that, it does automated feature engineering, and then tries to build the best model.
And when it chooses the 70%, it makes sure that it is random, or like it covers the training data, it covers all different types of input.
Yes, that's a good point. And so when the split happened, it does something called a stratified splitting. So where it observes the percentage of Y that is there with respect to the data sets, so that making sure that, say, for example, if you have 100 rows and 50% of that is positive, 50% is negative, it will try to keep the same ratio in train and test, both.
But did you specify what the Y was before splitting?
So we missed that, but there is an option. That's why I said that's a good question.
I did select.
You did? Okay, you did a good job. So there is an option, but the system internally there will be another option to select that. So there's another guardrail around it. So the system will take care of it.
But to answer her question, it also shuffles it and does it.
Yes, it does random sampling.
It does shuffle it. It's not just take the first 70 and take the second.
Yeah, it's not exactly that.
Even after shuffling, we don't know the actual, like, we have all the random data, right?
So it does a totally random shuffling, right? So if you give 100 rows, it will jumble it. Maybe you'll put the top one down. So it does a random shuffling on that. And then it does a stratified split, which is observing or maintaining the ratio of Y, that is positive versus negative, in the train and test the same. Because then that will be the only way we can get the best performance, right? Right, of course. Cool. So now let's try and run an experiment. So, okay. Not now. Cool, just so that I'm on the same page with everyone. So now we're going to try and build a model. So by saying that, I mean that we're going to start an experiment. So we click on the experiment tab, and then there would be an option to say new experiment. Is everyone with me? It should be the second tab on the top of the screen. Yeah? We good? So then there's an automated tour as well, which will guide you how to go about it. And we'll share the tutorials as well online, which has very detailed information on how to go step by step as well. So, excuse me, for this we'll say not now. And we're going to select first the train. If everybody is with me, it would be great if I can see some show of hands and making sure that everybody is on the screen with me. Cool. How about you, my friend at the back? Are you struggling? Are you good? Cool, cool. Okay, okay. All right. So now what we're going to do is, you see, we selected the train data set. We're going to specify a test. So we click on test, and we select the test set. Cool. Now we have to specify a Y column. So we select survived, and the auto DL engine is kicking in for driverless AI. Sorry. Sorry, what was that again? Oh, what was the Y column? Survived. Target column. Oh, that's why. Okay, okay. Yeah, sorry. Yeah. The target column is survived. It's to the Titanic data set, so we're going to try and model if we can predict the probability of survival.
So if like this doesn't do any data cleaning, right? So we have to do it in advance.
No. It does data cleaning as well. The whole thing is automated.
Like if this is all running around.
Yes. It does. It identifies all that. It figures out what is from, like, say, suppose it's a very sparse set, which is like bunch of noise and only handful of data in that makes sense. It will filter that and identify what are the ones which we could actually make use of. It may not be the best model, but it will try its best. We good? Everybody's on this page. We have selected the train and the test, and we have specified the target as survival. Cool. So now, with that, you'll see that there are a bunch of knobs on the screen. Okay, one which says accuracy, the other says time, the other one says interpretability. Accuracy, we can all understand, it will try to model the best possible model that it can, right? But that may take a little bit of time. So for today, we're gonna reduce that to, say, 2 or 1. Maybe we can keep it as 2. So for time, we'll keep that as low as well, because like I was saying, the objective is we all should be able to build 2 models and interpret and explain that as well. And then for the interpretability aspect as well, we're going to use the dial and scroll it back to low. And then I'll explain what does that mean. Yes. So we're going to start an experiment. As the experiment takes a little bit of time, I'll explain what does that mean. We good? So for now, so everybody is selected either 1, 1, 1, 2, 1, 1, some low value. If we select a high value, since an automated process, it will run multiple combinations, so it will take a little bit of time, right? So then, as you can see, the system has identified that it's a classification problem. The system also supports GPU, so for faster execution, because we run so that it could work even on a big data set and so many combinations, so it's computationally expensive. And the other important thing is we're going to click on the tab which says reproducible. That's like setting a seed so that the experiments are reproducible each time. Cool? And as you can also see, okay, so the other part before we start the experiment is that under scores, you'll see multiple options. You'll see that AUC is automatically selected because it's a classification use case, right? So with that, we're going to launch the experiment. Cool. So we'll leave this screen for a while, go back to the slides, and quickly explain what the dial means. If the screen comes back. Cool. So quickly, as we saw, accuracy is controlling the accuracy. So we want to build the best possible model. We spin the dial all the way to the end, put it on 10. It will try to optimize on the best possible model. Time is how much time do you want to spend in building the model. So if you again put the dial to the max 10, it will try all possible combinations. The third is interpretability aspect, which is that as we're building the model, how much of a black box do we want to keep the model? And there's a lot which is going behind this, is like, how do we capture it? Does it mean that we build features which are so obscure and hidden, that we're not able to even explain it? So that's a possibility, right? And what kind of model gets used? So maybe like if you put the dial all the back to 10, so it will try to build deep learning models as well, right? Or if you put it to minimal value, then it will try to build simpler models. So objective here is that we give user the choice to decide what works best for them. But we also provide the interface that no matter what we do, whether we build a simpler model or a most complex model, either way you have the option of explaining and understanding the model. So that's the core power or the aspect of driverless AI.
So on interpretability,
Questions?
number 10 means more or less?
More.
So with number 10, then it will not build deep learning.
No. So when the interpretability is, that is true. When the interpretability is high, then it's not going to do it, but it's low, then it's going to do it. Did I get that right? Right? Yes. So as you can see, so as I was saying, so there are two forms of interpretability. One is that even as we are doing feature engineering, how can we capture what kind of transformations do I want to apply? So if my dial is low, do I want to enable or disable the most complex operation, whether it's a log transform or a log square transform, or an inverse transform, as you can see from the chart that I've shown you guys. So that is one aspect of capturing interpretability with respect to what kind of feature engineering that gets enabled. Cool. Then the other aspect, so we call that native interpretability.
But doesn't this intrinsically depend on what kind of model you're going to build, i.e. a tree model or regression?
Yes, so the system is automated that depending on whatever is the type of model that is getting built, it will figure out internally what combinations to use.
But how do you know when it sweeps from one class of models to another?
So those are...
The number goes from 3 to 3.2, and suddenly switch over to how do I know?
You mean like for the type of problem or for...
So supposing you showed 3 dials, right?
Right.
So if you want kind of high accuracy,
Yes.
7.
Yes.
And interpretability of 7.
Right.
So how do you know whether you're using the class of GBM models, or are you using deep learning?
Right.
What are you?
So
There's a whole bunch of class of models in here.
Right. So what you're saying is absolutely right. So now you're understanding the complexity of it, right? So what we have done here is we have built those captured as recipes. So there are multiple recipes which runs in the background. And how we have created these recipes is by capturing the knowledge of grandmasters who compete on Kaggle on a day-to-day basis. So H2O has some of the world's best grandmasters on the team. And one is an expert in time series, one an expert in NLP, other in other forms of tabular data sets, and so on. And these recipes are created by capturing what they try to do when they try to compete. So when we are rotating these dials, internally it is selecting different recipes that may make sense. And since we have enabled, we try to use the power of GPU as well, so it enables us to run multiple computationally expensive operations concurrently. So that's one, like, one secret sauce as to how we go about doing it. So like even the aspect of feature engineering, that's completely automated, irrespective of whether it's a time series, NLP, or any other form of tabular data set. Yeah. So as I was saying, so there are two forms of interpretability. So as we were defining, the aspect of interpretability is to enable it as per the user what makes sense. So one is it's the complete system. It's not just one concept. We want to enable it in a human understandable way. So in this case, since we are talking about an automated environment, which means we give user the option of what kind of transformations you want to apply. Right? The other form, so like it's suggesting what form to use. But the other form that we're going to also explore slightly today is with respect to post-hoc interpretation, which means you have already built a model. And then we enable an interface through which you can dig deeper into it and ask questions. Why did you do it? Why did you did that? Right? You made a prediction for this particular individual as the probability of survival to be 90%. But can you tell me why exactly? Was it because of the occupation, the passenger class, because of the age, the sex of that person? What was the criteria? Right? So we're going to explore some algorithms. And maybe I should quickly go over the algorithms because of the time constraint. We may not be able to dig deeper into each algorithm, but I'm open to taking questions after we are done with the session. Okay? Because we said our objective is to build two models, right? So we have to make sure that we will be able to build two models. Okay, cool. So the algorithms that enable post-hoc explanation. So we touched on what is, briefly touched on what do we mean by native interpretability. So it could be a form of model as well, right? So now post-hoc, we enable that aspect of it using an algorithm called LIME. K-LIME is a variant of it. So what do we mean by LIME? So as I was saying, we want to enable the explanation not only globally, that is the whole data set, but for individual prediction as well. And LIME is local interpretable model agnostic explanation. So the explanations are agnostic to what type of model gets built. It doesn't matter whether it's light GBM, SG boost, linear logistic, whatever model we're building. It will still be able to generate explanation. And we capture those as reason codes.
You're not using the modern versions like shape or anchors?
So we use Shapley as well. Anchors we are experimenting. And trying to identify whether it makes sense. Will it be able to give a better result than what we already have? So yes, we are actively experimenting. So some of the concepts that I'll highlight on the screen, and one is called partial dependence plot. Does that algorithm make any rings, any bell? No? Okay. So what the algorithm does, it enables the ability to, as I was saying, understand the model based on the input and the output. So, and that could be a 2D or a 3D plot. Why 3D? Because normally we as humans can only successfully visualize a three-dimensional visualization, right? So, but conceptually it can be, it doesn't matter. So you'll see in this data set that we have, the z-axis is average occupancy, maybe some variable. And this x-axis is house age, and the y-axis that we are trying to predict is what will be the value of that house. And what it is enabling, since it's a model agnostic, it helps in understanding or computing what is the average dependence of the interaction of those two variables which are contributing to the prediction. So with that, even though the model has tried to do some hidden feature engineering, it enables me the option that, okay, driverless AI, you've built this model, now can you explain me? How have you captured that? And if it has done a good job, then we'll see that no matter what model you will build, if it is doing a good job, it will cover that, oh, you know what, if the occupancy is less, and the house age, if you've lived in the house for a longer time, you'll see that the value of the house would be much higher. So that kind of aligns with the truth. One other algorithm is leave one out covariate. So that is we call loco. And the idea, if you guys are following with me, so like imagine you have 100 rows, and that 100 rows is made up of 4 features. what if we switch off and switch on features as we are trying, so sorry, taking a step back, we use that 100 rows and we build a model. Now and the model is a classification use case, so each time I query, it's able to give me a probability scores, 80%, 90% probability of survival. So now, what if we switch off and switch on each feature? When I say switch off, so suppose you have feature A, B, and C. For feature A, make all the values 0. And then, excuse me, and then query the model. How did you do? Maybe the probability score will fall below 70% or something. Then you enable it back again and disable something else. So what we'll do is in some random order, we'll keep disabling and enabling feature and query the model, how are you scoring it. We'll keep track of it and then we'll rank order. That's what we call as loco. Yes, sir. Cool, okay. So another extension to that is what my friend here was talking about, Shapley, where what if it's not just one single feature, but it all permutation and combinations of that feature. So first it could be A, then it could be AB, it could be BC, ABCD, whatever permutations that we could think of. So if we have 4, so 2 to the power 4 permutations is going to compute and keep disabling and enabling those features and keep scoring it. When we keep track of the scores and we compute it back and we rank order. So this idea originally comes from game theory. And the initial implementation was done in 1953. But why it has become so prominent now is because what has happened over the period of years is building model is kind of becoming slightly easy, right? Because even with the driverless AI, we are enabling it, but now people are asking the question, oh, you built this model, but it seems like a black box. Can you help us explain it? So in order to bring in trust. The other problem is that in the industry, adoption becomes a big problem, depending on the kind of model that you're building. So in order to drive that, enabling trust and communication and generating that insight, it becomes very useful. The other important factor is depending on the domain you are in, you may have a regulatory concern as well. So for example, a lot of the financial banks, they have this thing that if a customer comes in and they have to ask a question like, oh, why did you deny me a credit card? They are liable to explain that. So I don't know if you guys how many of you guys here use Credit Karma to check the scores? Right? So if you go even now, today I was doing it yesterday, I got some notification that it has dropped or increased, I forget. But if you go there, then it will actually tell, there is an option which will say why. And if you click on that, then it will give you information. It may also recommend you to do what steps to take to, based on that insight. So what it is doing internally, it's internally trying to do the same thing similar, trying to understand what's happening and recommend to the user, enabling explanation. The other form is something called a surrogate decision tree. So what if you have built the most convoluted driverless AI model and you have tried I've tried Shapley, I've tried Loco, I've tried all fancy stuff, and still I'm not able to understand what's going on, and I want to see a holistic view of it. Because we as humans, we like to reason in terms of if and else conditional statement, don't we? I woke up in the morning, I went to Starbucks, had a nice cup of coffee and a banana bread, my day is going to be awesome. Right? So we think in terms of if and else conditional statements. And the idea with this surrogate decision tree is that since it allows us, that's what's the whole idea of creating this tree based, is to capture that if and else conditional statement. So if we can get is like, oh, if a particular feature was greater or less, then this particular thing happened. That might help us in bringing intuition as to what exactly is going on. Another quick extension to this idea is so I was talking about partial dependence functions, right? So the problem with the visualization in general is that we can only do so much of a good job with 3D, right? We as humans can understand 2D plot, 1D plot, but it's a 3D plot, we can do a good job. But after that, we start losing a sense of what we are actually looking at. So maybe there is a way where we can capture all the interactions that are happening in the data set early on and rank order it. Right? So if you are able to do that, maybe we'll able to do some other intuitive form of feature engineering as well. So these are some ideas we are currently exploring. Now, before we go back to the screen, we are going to build a time series model as well. So since we're short on time, let's quickly go back to our driverless AI environment. So if we have all been successful, we'll see the screen and a lot of buttons which have been enabled. Yes, sir.
When you say feature, is it exclusive to all the parameters in the data?
Say that one more time, please come again.
Features, is it exclusive to only the parameters in the data set?
Yes. Cool. So we all see the screen, right? So it's always an interactive environment with driverless AI. So we'll not be able to play through all the aspects of it. But if you'll go and even on the iterative, where you say iterations on the data, you'll click on each, you'll see the rank orders of the features changing. So what it has done is it has tried multiple different combinations of it and tried to give you the result on the best model that it could see. A lot of information is captured on your right column, so you'll see that the model has done a good job on the test score, which is around 0.99. So we had done a 70-30 split, and with that, we are doing a good job on the test.
How did you specify what was test?
Oh, you remember initially when we had taken the train dataset Titanic, we had split it, and then when we had started the experiment, we had selected it here on the screen here, test dataset. We had specified a test dataset.
Okay, I didn't remember the test setting.
Yeah, that's all right. So as I was saying, interpretability is aspect of the whole ML system within driverless AI. So for example, if you click on the ROC, it's an interactive environment which allows you to do threshold analysis. So typically when we build a model with a classification use case, we try to observe the ratio between false positive and false negative, right? And we try to see if we can, so ROC curve helps in identifying or doing balancing the ratio between true positive and false positive. So ideally we want to be on the top left corner. So if we are able to do it, because we want to get all the true positives successfully and we want to lower the amount of false positives, right? And we can check for train and test. There's an option to go to diagnostic screen as well. So if we go here, so test. See if I can quickly show you that as well. Okay, it's done. So the same ROC plot that I show you, now you have multiple options to actually play with and interact with. So the aspect of interpretability is captured within the whole system. The other thing that I wanted to quickly show you was, so we go back to the experiment page and there's a button called Interpret this model. If we click on that, should complete pretty soon. Almost done. All right. Did some of us, I know maybe I went a little bit faster, but did some of us were able to get to the screen? Okay, we got a couple of people. All right, cool. So, and we'll share the tutorial as well, but at least all of us were able to build a model, right? I want to make sure I deliver on the promise. Okay, so now if we say finished, we'll open up another interactive environment where if we go on the dashboard view, like I was showing on the screen, now you have the option to actually explore globally. So this is the global importance of the features which are rank ordered, but at the same time we can look at individuals as well and trying to identify, like I was saying, the reason codes. Boat and body, so for example, for that particular point seems to be the most contributing one, right? And I was talking about different views. I am not sure why I'm not able to scroll the screen, but if you guys are, at the bottom you'll have the decision tree plot, And then we have the partial dependence plot as well. And there you have the option of changing the variable. So you'll see that if you change the variable sex, you'll see that for the females, the probability of survival is higher, because if you remember or would have watched the movie, you'll see that initial preference was given to a lot of females and small kids. Right? Cool. All right. So let's see if this. Okay, so now since I've shown you some rough idea of the algorithms we talked about and how we can enable interpretation, let's now quickly go back and try and build a model for time series as well. All right, and let's see if we can do that together quickly. So we'll go back to our data set. We're going to click on Add Data Set, back to File System. And we're going to select, let me just make sure, what data set? Okay, so time series, now, go back. And okay, so we're going to go back to data, time series, Walmart, and there you'll find the last two options as Walmart small train.csv and Walmart small test.csv. So we're going to import both of those files. So import file should get done quickly. Then test as well, import file. Cool. Did some of us were able to get both? No? It's data, time series, Walmart, test and train, small. We have to select one by one. Yeah, but it should be fairly quick. We good? We good? Right? Cool. So what we're going to do is, because we want to run it as a time series experiment, we go back to an experiment page now. We click on New Experiment. And we're going to select first the train. Then we're going to click on Test. We're going to select the test. It's a time series experiment, but still a supervised learning problem where we are trying to predict weekly sales. The automated system is trying to learn what features to, like what combinations to actually enable now. So remember, time series experiments are slightly different because the data are sequentially related. It's not an IID. So initial execution is to how can we convert it into an IID, so that we can model it using maybe say LightGBM, SGBoost, or whatever different other forms of model that make sense.
So are you saying that you convert the time series into a classification?
Yes. I mean, in this case, it's a regression use case, but yeah.
So you're not using something like ARIMA or some other?
Not right now. So the thing with ARIMA or any other seasonal format is to cover what those seasons and patterns and are with respect to a time series data set, because like we're saying, we want to identify sequential aspect of it, reduce the sequential dependence on the data set. What it does, as a part of feature engineering, it does those smoothing and averaging and computing different lags automatically. So we do all that feature engineering and capture those engineered features as the transformed features to be used for the model. So as for this experiment, again, we will reduce the accuracy, the time, reduce maybe increase the interpretability.
So on the time column, you have to select anything?
Time, maybe you can just keep it as 1. If we spin the dial to low values so that we could
Where you have off time column on top. Yeah, that one.
Yes, target column. Okay.
Go right.
Okay. Yes. So we're getting to it. So in the time column, we're going to select date.
Okay. I did that, so I just wanted to ask.
Okay. So that's how the system is now converting into a time series experiment environment now. So now you'll see a couple of options on your right where it will tell you how many weeks do you want to predict. So let's just feel free to select any number. I'm selecting 12. And after how many weeks do you want to start predicting? So typically what happens in the time series experiment that often there is a gap. So with this Walmart data set, if I remember correctly, the data set is from 2010 to 2012. And the data sets may not be like, it may not have information for all the dates. So there will be a lot of gap in between. So in order to model that, we capture it like as a way to do the feature engineering in an automated way. We ask the users to specify after like, what kind of gap is like tolerable for you so that depending on which we can engineer the features. The other thing that we'll quickly change is the scorer. So we'll change the scorer from RMSE to R square. And why R square? Because R square, if the model is doing good, the higher the value, the better it is. So 1 is the best. It's slightly more intuitive for a lot of the regression use case. RMSE is also great, but I'll show you how for this experiment it should be all right. So we good? Yeah. Yes, sir.
What is the what happens after we reproducible or enable GPU or disable?
So the GPU is for handling the execution intensive operations. So when we disable it, then it's going to just use the CPU cores. If we enable it, so all these environments that we have, it has a core for GPU. Reproducibility, as we were saying, that there's a lot of random nature in it, right? We do a random split, we do a lot of random sampling. Even the selection of the algorithms, it could be random because there are so many combinations to it. So that the experiments are reproducible, we enable with a seed. So if you select that, then the pipeline is consistent. It will always give you the same scores no matter what. And you can ask or take the same setting to another person and do it in a different environment, he'll get the same model. So with that, we'll launch the experiment. It shouldn't take much time.
So did you answer that question? Does it use a Riemann abstraction?
Not right now, yeah. But what I was saying is that those seasonal effects, in regards to like, the moving average and all that all those features are captured beforehand. So as a part of feature engineering aspect. So I think if I remember correctly, it computes some exponential moving average when trying to extract the patterns from time series data sets. So it should get done fairly quickly.
So the experiment name is generated as it?
Yeah, that's auto-generated, but you have the option of changing it. So there are other aspects that, if you remember the second slide, I think I showed you like project management, where it's the aspect is that how do we manage so many multiple experiments? So those are some other new features that are coming, and we're going to be announcing more about it at the H2O World. So if you have not signed up and would like to know more about like what are the upcoming features, that would be a good venue as well. It's on 4th and 5th of February. It's in SF. Do you remember the location? It's on a website.
It's in Union Square.
Union Square. Yeah, and we have Saurav here. If you guys are interested, want to register, he's the right person to go to. And then we have Rafael as the back as well. So if all you guys would like to attend H2O World, please don't let those guys leave the building. Cool. So with that, if you build the model, then we're going to click interpretation. And hopefully this ends fairly quickly. I know, my apologies, we are shooting over the scheduled time a little bit, but I want to make sure that we build 2 models. It's almost done. A couple of more minutes.
So while I was doing that,
Yeah.
Are you allowed to use this for Kaggle competitions?
Yeah. A lot of our folks, they use it, and
How do they do?
they do pretty awesome. So that's one thing that helps in making sure that what we are delivering is tested and evaluated, not just something in our mind, but on an actual environment.
Yeah, Swami?
Yeah.
My question is, you are able to give me a model,
Yes.
but when I say interpret it,
Yes.
why are taking so long? Because you have all the data, all the history, all the features, all the
what have you done? You
Right.
know what you've done.
Right.
Why change so long?
Right. So it could be multiple aspects as to how interpretation is enabled. So, for example, when we are talking about Shapley, right? So it's slightly computationally expensive. So imagine that you have, like I was saying, you have 4 features. So if you try to compute all possible combinations of it, you're looking at 2 to the power 4 combinations. And each time it's going to switch off, switch on all those combinations, hit against the model, get the score, keep track of the score, do an aggregation on it, then rank order it, and then give the result back. So it's slightly expensive, but at the same time, as you're mentioning, colleagues of mine, they're actively working day in and day out as to how we can improve the performance. And we are also exploring into other algorithms and methods which will be much faster. So that's one aspect that you mentioned is also it's a post-hoc thing, so which means the model has built. So another way to enable it could be that can we enable it as an interpretable model as well. So the driverless AI engine also supports something right now called rule fit, where it tries to build if-else conditional statement models by default. Right? Cool. So now if we have been able to build this model, we should be able to see the screen. Right? So as I was saying, R square is a good metric because to explain and understand, because higher the better. So you'll see that for a lot of the use cases, the model has done pretty well. So this is timestamp from 2010 to 2012 for Walmart dataset. And for a lot of places, it has done a good job. And this forecast horizon window that you'll see, that's where it is using the test. So you remember we had specified 12, 36, or whatever it is. That's what is determining the size of it.
So what is the, clearly because you cannot shuffle and you cannot compute the data, therefore you're limited by the total number of months or time steps that you can use, right?
Yes.
So how are you are you imposing, so if I have a short time series,
yes,
what is the minimum you require for me to build a time series model? Like 60 or 20 or?
I don't remember from the top of my head what exactly is that number. I might have to go back and look into the recipes. Yeah, so I can follow up on that. There was one more question at the back, and then I'll get to you.
When you mentioned about Shapley,
Yes.
after doing that, does it actually rebuild the model and then
So that's the trick. So like if we disable, it's like we can just score it because if we go back and rebuilding it, that will be computationally more expensive. So it doesn't do that. What we does is that we disable it by putting say 0 is as good as not using that feature, because 0 or any other constant feature for all the rows. So that's one trick that one could use in disabling a feature. Just make it redundant for all the rows.
So usually the model remains as is, like the weights and all they don't change.
Yes. You had a question?
And you earlier were referring to a GPU. Are you using a particular GPU?
You mean like what kind of hardware it is?
NVIDIA?
Tom, if you can.
Yeah, it's using just one of the NVIDIA GPU instances in EC2.
Okay. So these are EC2 instances, and then we're using NVIDIA. Cool. All right, so as we're saying, we want to see how we're doing with respect to a forecast horizon. So typically, with respect to time series data sets, we want to study the evaluation of that particular model with respect to groups. So in this data set, since it's a Walmart, department and store is one group, which constantly gets used because we want to understand weekly sale. And date and date, department, and store plays a big role on that. So these values that you'll see here, 14.7, those are actual IDs for department and store. And as you can see, the R square values. So higher is better. Since we had put the dial to 1 for accuracy, so it's not that good performing a model. So you'll see that the value here is low, but RMSE square values are higher. So that's one way of enabling interpretability by observing what are the top and bottom group metrics on the test data set. So you'll see 10 values here. The top 5 are the best performing values for the different groups, unique groups, and the bottom ones are bottom 5, which are worst performing groups.
Sorry, what is the model trying to predict?
So model is trying to predict the weekly sales, but what we are trying to capture here is that, okay, so it did something. It tried to say that we forgot to check what it did, how did good or bad it did on the test data set. But now we want to see, okay, it didn't do well. Can you explain? So what we're trying to capture here is that how did the model do for different groups, which are important.
So the model is not just, it's got some kind of factors like department stores.
Yes, those are the features.
Well, okay, so I'm confused. Time series means something totally different. Are you talking about multivariate model here, I guess? It's not, it's more than, anyway.
So it is a time series experiment, but it's a multivariate use case because it uses number of features along with the time. So what I'm trying to say is that when it's trying to model this use case, it's just not based on time and weekly sales, right? It's trying to consider other factors as well, and then convert it into an IID format data set and then build a model on top of that.
So then the question is, how do you include those like 10 or 15 factors like department store and all?
Yeah.
Along with this thing? How do you, what's the model there?
So that will force us to go into the details of the time series recipes that we have, and that is a session just in itself. Right? Yeah.
So the nice thing is that they show World London.
Yes.
Marius did a time series session.
Okay.
The replay is there.
Okay.
So definitely look up H2O World London.
Cool.
For the time series session, and then look at that session.
And maybe we can also do is like maybe send those videos or tweet about it as well or something. On the meetup page, yeah. So that would be great. So that way you will know what exactly went through. So my apologies, just slightly difficult to cover the whole aspect because these are very involved recipes that we have built, not only for time series, for NLP, for other formats. And it has these recipes are developed after a great amount of hard work. So yeah. Yeah.
Come to this screen.
So this one is the same interpret this model button. Since it's a time series experiment, it's a different form of interpretation, where we try to observe and understand for what groups of data set, in the data set, the model is doing good or bad, because typically that's what we want to understand. So now if we click within the forecast horizon, we have the option of, like I was saying, showing 14,7, right? So let's do that quickly. So then we'll show actual versus predicted. So you'll see the actual was 6,000 something, and the predicted is 9,162. So the model hasn't done that good of a job, but we didn't expect it to do because we selected pretty low accuracy. Then
Average predictions over a forecast horizon?
Yes.
Or just one individual sample?
Say that one more time, please.
So you were just saying that actual was this much, versus predicted was this much. This is only for one time step. I want to aggregate it over a 4-year horizon. Can you do that? 48 of those samples, values will be aggregated.
So the values that are here within the forecast, those are the ones which gets shown here. This top and bottom are the values which are within this forecast window. So if within the timestamp, as you mentioned, if your test set is just comprised of 4 weeks, we'll be just trying to understand how the model is doing good or bad with respect to those groups in that forecast window.
So that was just one individual.
Yes. So and the thing is that we have done more improvements on it and more adding more intuitiveness, and we'll be showing some of those use cases at H2O World as well.
Can you speak to how stable these interpretations are? For example, if I introduce more training data,
Yeah.
will the interpretation change very quickly, or?
So if the model accuracy changes, interpretation would change as well.
But are these interpretation is for my entertainment only, or can I actually show this model to a real customer?
I would say you can show it to a real customer. Yeah. So like you were saying, like, what are the attributes which are getting used? So for example, in this way, a lot of the moving average weights are covered, like it shows as target, lags, and department store, and these are all different cluster indexes that it has tried to use as it has tried to do a lot of feature engineering. And these are computed again using Shapley scores. So these are actually for an individual point. So I'm trying to understand for this department in store 14,7, what are the actual versus predicted? And for individual points, can you give me more information as to what are the contributing features?
So the key is that you are applying Shapley to exactly one of those forecasts.
Yes.
So that answers my question. Now, there's something with that challenge at my current place.
Yes.
Okay.
You have a forecast over your model was built and evaluated over that forecast horizon, which is say 48 values.
Right.
And now you're trying to apply Shapley on the other hand on one of them.
It's not on one. If you go up, you can go up to the screen. This screen, you see the white values as a predicted value.
Yes.
And green values as a model up
actuals.
to before the forecast horizon. Yeah.
All the values from left to here,
There is the
train.
data. Right?
This is the test.
Here onwards is the test data, and on the test data, so you can see how the shape of, if you just go to focus on that area.
The model's accuracy was evaluated over the entire horizon together.
The model
Only the forecast horizon, yes.
Only the forecast horizon.
Yes, the entire.
Shapley, if you read the paper,
Yeah.
is for classifiers, which means exactly one value. So ideally, in order to port Shapley to the time series world, you must extend it and apply the concept of Shapley to the entire series, because you're creating a model of the entire series over there in that forecast. Right?
Sure. But the thing is that it works for global or local as well, depending how you want to do it, because what one is observing is the change in probability. So if it's a local, it generates a bunch of internal samples around that space and then computes and observes the change in probability score. Because the concept in general is totally agnostic. It's like, okay, I'm going to switch off and switch on multiple combinations of the features and observe the change in probability score. So now if it's an individual point, I can still do it because I can either query from my test set, give me 100 samples which are similar to it. And that's what it does. It queries for 100 samples similar to it and then builds a model, observes the change in probability scores and rank orders. So if you don't want to do it, if you have the whole data set, it will not query for more sample and rank order. So with using one algorithm, we can compute it globally and locally.
I have a question.
Sure.
One, this data, let's just take Walmart. You have this different department, you have the
Yeah.
product, you have the markdowns and all that, but that's all historical data. If you were to predict the future, that's what the machine learning, and you do not know how the economy is working, how the consumers are, how the trends are changing, how the forecast is changing, how the weather is. How do you apply those kind of things to this machine learning?
So that's a great question, and let me answer that question with this slide. So what does the future look like? And what you mentioned is absolutely right. So what we're talking about is there is a paradigm called exploration exploitation policy, right? So some of you might be aware of like reinforcement learning algorithms, banded algorithms, and so on. The idea is that as the environment is changing, how can I ask these questions? Like you mentioned, maybe another variable got introduced. Maybe some variables are not needed anymore. So the question that we are also forcing ourselves and trying to think hard, what does it mean? Like, how can we generate this idea that, like, we are generating this explanation, this insight, it is giving us information, but what does it mean to move next? Can we generate recommendation based on that? So hence the question is like, and it's an open question to all of us here, and because we can't do it alone, we will need constant feedback. So if you guys have ideas, feel free to reach out to us in different ways, but we are trying to understand, can we convert this idea into a simulated playground where we can infer, evaluate all forms of model, do different scenario analysis, what if analysis that you were saying, identify counterfactuals. So for example, what if I flip a variable from point 1 to point 2, and does that model prediction change? right? So if we're able to do and think in those terms, then maybe we are trying to enable model robustness, because all models are generally wrong. It just depends on how much data we have tried to capture building that model. So if we can enable that, then maybe we are enabling ourselves a very powerful tool.
Again, I don't want to take up all the time. Historically, when we go and look at, I come from the high-tech industry.
Sure. Sure.
One of the biggest challenge you face is the high-tech and the forecasting the
Yeah.
high-tech. And there is in the MBA classes they teach, what's the best method? It's called the Delphi method.
Right.
And do you know what the Delphi method is?
Not exactly from the top of my head ideas.
Opinion.
Right.
One who has been there and has the best gut
Okay.
can predict the best of the future.
Right.
And you go back and that's how we have predicted it. All the forecasts that are done today and where they just do a linear and all that, they're all wrong.
Yeah, most likely.
They never take into account how the entire world and the things are going to change.
Right.
So this is where machine learning is going to be very interesting. Who can really apply the right models? And because it's all historical data.
Right. No, what you're saying, you're absolutely right. And that's one big challenge, right? Like, especially solving business problems, that the environment constantly keeps changing. Even if you're trying to optimize market budget or something, like marketing budget or something, maybe there is an external factor which comes in. It's Christmas. But I'll say this, that in the driverless AI, I was not able to dive into the details, but even when it was trying to do time series, it tries to capture some of that seasonal variability. So like it tries to identify, does it is it a time of holiday? So there is a factor where it tries to evaluate, where is it a holiday? Because a lot of things change when we're trying to predict sales if it's a holiday. So it tries to capture a lot of the seasonal variabilities. You're absolutely right. Yeah. So let's keep the discussion ongoing. I don't want to keep all my other friends waiting. We have gone overboard the scheduled time. So here are some quick references. I know we were not able to go into the exact details of everything, but we're gonna post it on the meetup page as well. What I wanted to show you was trying to escape out of my screen. Just give me 1 second and show. Yes. So we'll share the slides. And on the slides, there is a link to the GitHub repo, which is this one. If I can go to the tab, which has a lot of the details captured and explained, so that you guys can try it on your on your own time, as time permits on your end. And I think the license might be valid for 2 days, so make most of it. And if you like it, please. Or if you like it, if you don't like it, please do give us your feedback. So with that, I'll end the session, and then maybe we can take all the questions, as we hang out near the pizza. Sounds good? Thank you so much again for all you guys. Let's take all the questions after the session, because my other friends are waiting, sort of. So thank you. I wanted to thank all you guys again. I know it takes a lot of effort to make time in the evening, hassling through traffic and everything, and it means a lot for us that you actually chose to spend your evening with us. So thank you again so much. And with that, let's continue the conversation with pizza. Thank you.